Hello everyone. So today we will continue doing the video series talking about the design data intensive application book. This is the 2026 edition, and in this moment we are seeing actually the overview that how you can implement event sourcing and CQRS architecture. Take a note that this is not this is a design that involves multiple entities, and it's not an easier way if you want to start with an application. Okay, take a note that big and complex application designed to implement this kind of system if you have a need and a strongly audit log of if you want to replay multiple events to generate a projection of this kind of data. And please check this video because I will reveal how you can implement if you have a privacy law that you need to remove data from the some user, but you are working with immutable events log, you have to implement a kind of hit to not maintain the data and event log available for everyone. Okay, so we can go ahead with this video. Okay, if you are working with this kind of system, actually you have to take a note that you are working with a state-based database. Okay, so in this case, for example, if you are updating the database, you will lose each chain that you want to do, the history of that chain that you are doing previously. Because in this case, for example, if there is an updating, you will overwrite actually the column, and there is no way to to recover actually which kind of value was there before. Obviously, we are not talking about the backups, right? But in this case, take in mind that you always working with the latest snapshot of all the state that you have in your system. But if you are working with event sourcing, it's like an appearance reel. It's like you can store all the events that you generated in your system, and actually you can replay all the event that was generated in a time that you wanted actually. So that is in taking that in mind, you can think that there are multiple advantages if you want to implement this kind of system. Obviously, there are disadvantages, okay? But in the case of the event sourcing, the events are the true of all the state of your system, okay? Okay, if you're working with a big and complex system, it's very common that not only have a single model of a database, that you can work with a relational model or the document model to optimize actually the writing or the read. But in any case, you will have a disadvantage in each model that you decided to use. Actually, if you decide to use relational model, obviously you can optimize the case of the writing, right? But there will be a painful if you want to have, you have to a heavy number of the joins to get the data. And if you want to work with document models, obviously there you can optimize with the readings, with the read request. But if you want to create multiple, if you want to support writing, you need to create maybe batching to update a huge number of documents that is then normalized. So take in mind that not only just necessary to have a single model when you are composing a complex system. Okay, so in this case, that in that scenario is appears the event sourcing solution and the CQRS architecture to handle it, the optimization of writing and the reading. Okay, but not always sounds good actually, okay? But in this case, when we're talking about event sourcing, is that every state of the chain is like an event, okay? So if there is an addition, if there is an updating, if there isn't something that you want to delete, actually it's um, transformed like an event that occurs in your state, okay? And it's like an logs of your event, and that means that it is the source of truth. And the state can derive to generate multiple projections and replace multiple events, right? And we're talking about CQRS, is when we split actually the table and split to not only have a single model. It's like maybe we can have a model to maintain the data that you are written, right? And another model to only pull the data. It's like if you were working, for example, with MongoDB because it will be faster to handle it than read request. You can handle that, and if you want to optimize it to written and you want to create multiple number of events, right? Maybe you decided to use something like a Postgres, or actually you can decide to use the partition of Kafka to maintain all the logs. Actually, it's very common to decide to use Kafka in these cases, but no, it's not only the unique decision to decide to store this the source of truth of the events. Okay, actually, CQRS means command query responsibility segregation. Is when you split the request that you need to update or insert data, and another request that you only want to read data. It's like to fetch data or retrieve data. Okay, so with that approach, maybe you can support multiple databases. Okay, maybe a database to only push the request that you need to update, and another one to pull the data. But take a note that the multiple databases need to be synchronized, right? And we are talking about the eventual consistency. Okay. Take a note that if you want to implement something like a CQRS, maybe the main problem it will be if you want to create a command server, okay, or command services. In this case, a command is like an accrued when you are creating an endpoint and you only support the post and the put. Okay, so in this case, it's the same thing. Take in mind that okay, this concept comes from DDD. Actually, it's an architecture pattern that you want to have the split the responsibility of the commands that you want to receive in your system, and the domain that have the responsibility to decide which command it will pass and will finally emit like an event. Okay, so in this case, everything is starting with a command. Okay, the command is a request, and in this case, for example, I have an example here that obviously always have to be in a present tense because it's something that you want to do. And in this case, it's like, okay, I want to reserve a number of seats. And in this case, 50 seats for the user in this case. Okay, so it will be handled by this aggregate. Aggregate is like the part of the domain that it will decide if this command can be passed actually. But in this case, the aggregate domain actually need to be pull all the events that necessary to be validated. It's like, okay, if you want to reserve the seat, you have to take a note that if you have a seat available to be reserved. Okay, so in this case, aggregate need to be replay all the event that was generated before of this command to finally have the final current state and validate if it can meet this event or store this event. Okay, so the last step, it will be emit the event when this command passed, and the event always need to be like in a past tense because it was emitted. Okay, when I talking about emit event, it's not only just okay, I will emit an event or a topic to Kafka or an event of to RabbitMQ, right? No, in this case, when I'm talking about emit, is something a way or designed to or when you thinking about where you will store this event logs. Okay, this event can be stored actually in a database, right? If you decide it, and you can create a CDC server like in a Kafka, right, to receive this all chain that was generated in this table, right, and this table event log to push to different different subscriptions of server that need to have this topic. Okay, but take in mind that when you emit something, it's like an emits the event and it will be stored in some place. It will be emitted like an RabbitMQ. It will can be emitted like an Kafka topic, or can it be emitted only in a single row in a database? Okay, so you decided that, but it's only an append new event, something like that. Okay, so that's it. And maybe you can see in the list of the event log something like this. Okay, you can see that, okay, the event was created in the conference created, registration opened. So you can actually, in this moment, you can see it's very easier to see, okay, which will be what is the history that occurred in my system, and the reason that why I have this kind of the current state. And that is the main advantage that you can have with event sourcing, that you maybe you can resolve with the regular database and the current state with there are ORM framework to support audit and create a system of logs or updating of their columns on the tables. But it's like a custom approach to support something like an event sourcing. Okay, so in this case, the event log. A feature of this kind of system is that it had to be always sequential sequential. Okay, so in the order of these events, it occurs always the event is ordered actually at the moment that was generated. So that is a good that is a good feature, because you need to replay it. You need to replay in the future if you want to create what is the current state. And actually, it's immutable. There is no way to update this kind of event. Actually, if there is an error in some event, the unique way to resolve it or fix it is to create another event to fix it. And the benefit that you have, the advantage that actually you have, if you need to audit something, you can actually find a bug that occurs in some place. It will be easier for you actually to know, okay, what's happening and how you can reproduce it um, to finally understand what's happening in your system. So that is very, very good. Um, so if you want to actually show this kind of data in the UI, maybe you need to have the current state. And there are multiple ways to do it. Maybe you can decide to do it manually. It's like creating a server, read this event log, and always that you need the latest state, you need to replay all the event that was generated, okay? But there are disadvantages if you want to decide to do something like that. So for that reason, we created the concept of projections. Projection is like a derived view that was generated with the streams of this event log. It's like if there is an addition in this event log, it will generate an stream, a synchronous stream that multiple servers it will be handled, and it will be update their data model. For example, we can create an event log on Kafka partition, and there will be another side of projection that it will be consumed this topic, right? This partition, and it will generate an table or document model using MongoDB, right? In this example, or you can create a real-time database that it will be consumed for analytics. I don't know, or you want to create a dashboard optimized for only read model, right? With this kind of event log. Okay, so you can decide it. In which place do you want to replay this kind of event log? And in this case, you don't need actually always to need replay. Actually, the derived view is always get the latest event of this stream, and it will be updated in our site. Okay, but the advantage of this kind of model is that you will have a data model that is optimized to read, and another data model that it will be optimized to write when you create multiple events log. Okay, so that is the advantage. So maybe the next question is, okay, what happens if you created a huge number of events? How you can coordinate with multiple servers? and consumers, because actually you can create a projection server that expect something something structured of this event. So for that reason, we have the schema registry entity that is in a server that you can you can deploy it in your architecture to have the responsibility to validate if the schema of the or the version of the or the event that you want to produce, that it will be the source of truth, right, that was generated in this system, it will be compatible for the rest of the consumer that needs this kind of events. And that is actually this kind of compatibility. There are multiple modes. Okay, in this case, there are forward or backward. Okay, in this case, the very common to support this compatibility is the backward mode. That is actually always need to be supported the old event, because if you can change the structure, actually it will be have an impact in in multiple consumer that maybe need this kind of events. So for that reason, this schema registry, it will be validate the structure of the schema. Okay, and actually you can actually send um, actually, in this case, you can send JSON payloads of these events, but not only exclusive for JSON. You can actually send proto versions of these events. So take in mind that not only JSON is supported in this schema registry. Okay, and each event, actually updating of this event, it will need to have an version, okay, of compatibility. So in this case, when we are talking about the schema governance, is that there will be a server that in this case is schema registry, that it will be validate this event that was generated. Okay, and that's fine. And actually, the schema is not schema registry is not only live in the part of the architecture of your system. Actually, also lives on your continuous integrations flow. In this case, if you submit merge request, it will need to be validated if the event schema it was updated, and it will be actually validated in the schema registry to be finally deployed in your application. So that it will, with that, you can generate a strongly system that not generate multiple failures in other consumers that depend of your events generated. Okay, so that's it. And we have to talking about if you can handle it the concurrency control. And actually there is another advantage if you want to generate this kind of actually there are advantages if you want to implement event sourcing that you don't have with another kind of architecture. In this case, for example, they can mind that there are two paths, okay, two events that tries to be emitted, okay. So like I said before, each event need to be have an aversion. What's mean when I'm talking about version? Version is generated in runtime because when you are count the number of the events of this entity. For example, you are updating the number of seats in a reservation, right? The version, it will be the number of events that was generated before. So in this case, for example, this is the version 3 because there are two events generated before, right? So in this case, two events, concurrency events, will have the same version, the version 3. But we know that there is only a single event, it will be emitted or stored in the database. So at the moment that you emitted the event, you stored it in the database. In this case, imagine that you created a event log in a relational model, and you are creating a table that have the unique validation that only have a single version with this entity, right? There is not the possibility to have the same version in the same entity. And in this case, the happy path it will be stored, right? But in the second event, it will be fail, because actually it will say, okay, but we already stored a version 3. So if this event it will be processed in parallel, only a single one it will be successful, and it will be stored in the database, because we will restrict it. We have a limit in the database to not support have two events with the same version. So in this case, when it fails, it will generate a retry command to pause again the validation of the aggregate, right? And the advantage that any event that you emit not will be synchronized and it will be have the same rules, right? With the latest version. Okay, so in that case is an advantage with event sourcing. But take in mind that there are disadvantages and there are ways to handle this disadvantage. Okay, in this case, take in mind that if you have a reservation of seats, okay, and the number of seats that you can reserve and can be released for another reservation, it could be a huge number of events, okay, can be handled by a huge number of seats. So in this case, take in mind that there are a time that there could have I know 100,000 of events to finally to get the current state. So in this case, obviously, it not will be optimize it actually if you need to always need to be replay it all the events to finally to get the latest version of the aggregate, and finally to validate if you have seats available to be reserved, right? So in this case, we have the concept of snapshot, and you can actually create a logic to you have for each 50 events you can create or update a snapshot, and when you need to replace something, you need to use the snapshot version and pull the event that was generated um, after this snapshot, right? So, but obviously, the problem is of snapshot that always need to be compatibility with the old, with a new version of the event, because it could be generate a problem because it can breaks if you change the structure of the event. So take in mind that when you create a structure of event is something that is like in a relationship, like in a long term, right? Because need to be supported always, and it is not recommendable, and it's not a recommend, and that you create a snapshot at the first time. Only when you really you need it. Okay, that's all. Okay, we have to talking about what you can do if you want to handle other edge cases when you are working with event sourcing. For example, if you have an external dependency with a data that you need to um, pull it in your event log. For example, you are working with currency, right? With dollars of United States, okay, and you need to support the conversion rate of other currency of the world. Always you need to have the dependency to validate what will be what is the current rate in this moment, right? So in this case, there will be need to have an API external dependency. and your replayed event of event and not have it's dangerous to have this dependency, because always that you replay your event, it will generate a different current state, um, because they have an dependency that is dynamic and always generate a latest version. So in this case, you have to compose your events log with all the data that have an external dependency, to not have to not need to have to call any API when you are replaying your events. And actually, that is a part interesting when you are trying to working with an privacy law, that you have to support the possibility to remove data if the user or the account decided to not um, uh, keep the data in your system. So you have to maintain the immutable logs, but you need to handle it to hide the data, to not be the sensitive data not be exposed for everyone. So in this case, you can create an event with an with encrypted, right? With a hash encrypted, and this hash could be stored in your database. And at the moment that the user decided to not keep the data in your system, you can remove actually the hash to decrypt, and the sensitive data not will be decrypted anymore, because you already removed the key to decrypt the data. So in this case, that is the way to handle this kind of problem. Okay, but that only works if you are working with sensitive data. Okay, and you can replay the data, because you don't need to decrypt it. Okay, that's all. Okay, so the decision is in your side. In this moment, you can decide to continue doing your data system using states. Okay, or if you want to decide to use event sourcing, but there are multiple uh, multiple challenges that you have to achieve to finally to compose an system that will be supported and long term, and not need to have an problem with the data that will be consumed with by multiple projections, right? So that's all for now, and thank you for watching this video, and see you in the next video. Bye bye.